In this video, I'm going to go over the solutions to problem set 1. So those are all graded. Your grade should be there on Moodle. And I tried to make some comments as to what was going on. I'll talk today about some of the problems that happened on more than one person. Okay, so I think it makes sense to do that. Okay, so I think on the first set of problems, we had the point type, circle type, and cylinder type. A lot of you guys did a has a relationship, which, I mean, it makes sense. That's how I started off when I was working on the solutions, because a circle has a point, right? But what the book wanted you to do, and what the exercise, the point of the exercise was, is to do an is a relationship. So instead of, so you're going to be doing inheritance. So you're going to have a superclass, subclass, okay, not composition. So that was the point there. If you did composition, I didn't kill you on points, but you want to make sure that you understand how to do the composition. Okay, so I thought for this, to save time, not to see me type all day, let me go ahead and I'll look at the point class, and I'll tell you what I did. If you want to include this in another program, which you need to do, you want to get rid of the test code that you put in it. I tested every class inside the class definition file with a CPP file. You could also do a .h file. I'm not sure. There's good arguments each way. But after I did that, when it was working, I took the test stuff out, saved it as a different name. Okay, just so I had that to include. Okay, so this is the one that has the test. Okay, so again, our class point type has x and y coordinates. So we have int x, int y. You could go ahead and probably should. It's not a bad idea to go ahead and put in some, whatever you want to put in here. I mean, you can, all that you want. What I do, so this is what I'm going to recommend that you do. Just make sure you keep track. The first thing I do when I'm doing a class, I go ahead and put in labels or comments for accessors, mutators, other, and constructors. Helps me just to work things out. So accessors always look the same. They return the type of the data. So we have ints in this case, get x and get y. They just return the variables. Again, we need those because x and y are private. They can't be seen outside of the class. Okay. We have the mutators to set x and set y. We don't have to do that if there. I mean, in this case we do, but if there were data we didn't want the users to be able to change, we wouldn't put an accessor there. It's also the place where we would put in some tests to see if we need to do anything. In this case, the point really can be anything. If it's an integer, it can be a negative, it can be it can be 0. So I didn't put any tests in there. Okay. And then the book mentions printing out a point. So I went ahead and did a show point that's just going to print out the x coordinates and the y coordinates. Again, since I'm inside the class, I don't have to do anything. I don't have to use the gets. I can just say it. Okay. And then I have a couple of constructors here. There's a default constructor, okay, that just sets them to zeros. Then there's another constructor that you can send in the x and the y values. Okay. So once you've done that, you have to test all of those, right? So it starts off, I'm going to test both constructors. It's important that you test all your constructors. There's the default constructor that goes to 0 to 0. And then there is the other constructor that takes the two integer parameters. Okay. I then show that point. I'm then going to do the set x, set y, change those. Okay. And then instead of doing the show point, I haven't used the get x and y yet. So I test those to show what those new x and new y are. Okay. And then I show the point again. Okay. So that should test things out. That works. That should be good. Okay. Yours can be different for sure, but this is the basic idea. Okay. I thought I would actually go through. I shouldn't have changed anything. Okay. And do the circle one. That one shows the inheritance issues. Okay. Where some of you run amok. Okay. Okay. So I'm including CMath because we're going to be calculating circumference and area. Oh, that's a point. Some of you had circumference and area as member data, okay? And that's not what the problem asked for, and it's in general not a good idea. The reason it's not a good idea is if you can calculate it from data that you're already storing, okay? So if we're going to store, in this case, the radius is all we need, we can calculate the circumference and the area and not have to waste storage, okay? So we want a function to do that. rather than having member data. And you'll see what I'm talking about here. But I need to see math there to be able to calculate. You don't want people to have to calculate for some of your programs. You would have to calculate the area and the circumference independent of your program and upload it, which is not the point of this. Okay. I'm including the point type.cpp. It's got to be in the same directory, and it can't include the int main. If so, there'll be two int mains in this program and it won't work. Okay. So in this case, I'm going to do a class circle type. Okay. And I want it to inherit. Okay. This is an is-a relationship. So a circle is a point. I know that doesn't make a lot of sense. The cylinder is a circle makes more sense, but we're forcing this issue to understand how this stuff works. Okay. We want to make it public. If not, everything is private. We can't get to it at all. Okay. So we want it to be public. And then we're going to base it on the point type. Okay. Here's the next point where people got themselves in trouble. Okay. So again, put the accessors. I do this every time. Other, and finally constructors. Remember, we don't need the destructors anymore. We thought we did, but we don't. Okay. So I like to start with the constructors just to make sure that I'm on the right path. Okay. So in this case, we have to call, okay, the superclass constructor. So we have to call the point type constructor. If you don't do that, and I saw a lot of you doing this, either your program doesn't work right, or you have to make things private or public when they should be private. All kinds of problems happen. Okay. So here's how we do this. So again, this is called circle type, just like we would expect, with no return type. Okay. And we're not going to take, oh, we are going to take some things. We're going to have, so since a circle is a point, has to have an X and a Y. So we have an int XC, we'll call it, an int YC. And then for the circle itself, we need a float for a radius, R for radius. Okay. So we can't change the XC and the YC, the X and Y positions of the point from within the circle constructor, but we don't have rights to it because we're not that class. We're a subclass of that class. Okay. So here's where we're going to have to call the superclass conductor. Okay. On the things that it can take. Call that with point type. And it's going to take the XC and the YC. Okay. So the things that it can do. So when we create the circle type, we're going to send it up to the point type to create the point. Okay. All we're left to have to do with then is to worry about R. Okay. So our radius should be greater than 0. So we're not doing a ton of testing this semester just because it's going so quick, but we want to do the basics. Okay. So if it's greater than 0, we let it equal to that. Got an else here, and I'm just going to default. You could put an error message, that would be better, but I'm just going to say radius equal to 1. Okay, just to avoid putting a lot more code than necessary at this point. Okay, so there's our circle type constructor. The next thing I'm going to do, I'm going to test it. I'm going to make sure it's working. So I'm going to do my int main. I'll return 0. Close that. Okay, and I'm going to do nothing else except say circle type C1. Okay, this one, and it's going to take, say, 3, 3, 5. Oh, sorry, 3, 4, 5. Okay. So that's going to set the X value of circle type being equal to 3. It's going to set the Y value being equal to 4 and the radius being equal to 5. Okay. And because C1 is a circle, which is a point, I can see out here C1 dot get X. So all the functions that I can do as part of a point. Okay, let's see out C1 dot get Y. Those work here. Okay. Check this out, make sure it works. Oh, I bet I forgot. put in, yep. I didn't ever end a class. Okay. Just in a tab there to get my spacing back correct. So it's like something. Okay. So I'm on line 20. There's no radius. Oh, of course, because I lost my mind. I started doing this video before and got a little way through and then had to stop it. So I've totally forgot what I've done, what I haven't done. So we have to do our private. We haven't set up our variables. That's our issue. Okay. So private, all we're adding is a float for radius. And then for the public, we'll have this stuff. That's what I'm missing. Okay. Hopefully that's it. Okay, looks good. And we get the 3 and the 4, the X and the Y. Okay, so that's all working. Okay, so now I can go back through and start adding my accessors. They're all relatively straightforward. It returns a float. Okay, all we have is a radius. We'll be putting in there. There's nothing but return radius. That's all we have, nothing else. For the mutator, a void function, set radius, which takes a float r. Okay. And this is going to look very much like the constructor does. So I'm going to copy, or in Emacs terms, kill, yank, up here and yank it again. Okay. That should work okay. Okay. For other functions, now here's where our area and circumference is going to be. Okay. So I'm going to create a float function called area. Takes no parameters. It uses what it has. Okay. It's going to return. I've included the CMath. So m_pi is as the pi in as much detail as it can hold it. Okay. As much accuracy, precision. Okay. Times radius times radius. The pi r squared. Okay. We return that. That's our area. The circumference. Then it's also a float. It's going to return 2 times pi times radius. Okay. While I'm here, I'm also going to add a print. Print function takes no parameters. Just going to say cout. Do a new circle, a new line, and say the word circle, so we know what we're dealing with, because we have multiple things we're printing. And then I'm going to cout radius. Tab. I put 2 tabs. And the value of radius. And end the line. Cout the position. 1 tab. In this case, I'm going to make it look like a point. So I'm going to do a left parentheses, this dot get x. I need the this because it's not, I have to call the function. I think I need a this. I don't know, it's an interesting point. It works with a this. I don't know if it'd work without a this or not. I think it has to have something to attach to. Okay. This will work for sure. May not be necessary. And put a comma, space, this, get y. Do the closing bracket. Okay, so now my test program, I'll just come down and say C1 dot C out. Well, I can go ahead. Say C1 dot print. And I can C out area C1 dot get area. And then C out circumference. This is one tab. C1 dot get circumference. Okay, see what that does for us. Okay, does not like those. Did I just add those? Maybe. Oh. Yeah, I don't like get. Those should just be area and circumference. So let me fix that. You can do which one of those. Okay, so there we have our circle, radius 5, position 3, 4, get our area and our circumference. Okay, and I actually tested those prior on my version of the program, and that worked. Okay, so that should pretty much do it. Okay, I think that's testing all of our programs. Oh, I didn't do a set radius, so we should go ahead and enter our program. We should have them enter a radius and do a set radius. I think everything else is being tested. Okay, so I won't bother with that in the efforts of saving some time. Okay, so again, the big thing there is that we have to derive it in this way with a public inheritance, and then when we do the constructor, we have to call the superclass constructor. Okay, and then one more level is going to be with the cylinder type. Okay, so again, it has to include the circle type. You don't have to include the point type because the circle type includes the point type. Okay, and if you include it, you're going to include it twice and could cause trouble. Okay, there's the whole if not defined directive, which we haven't talked about yet, but that you can do that to avoid things being included more than once. Okay, so we're also including CMath because we'll do some math again. So again, like before, class cylinder type is going to publicly inherit from circle type. Okay, and then what we're adding here is height. So we have an accessor of get height, we have a mutator on set height. Again, I'm making sure that it's on not less than 0. There's the calculation for the area, calculation for the volume, and here's our constructor. Okay, so it's this time the cylinder is going to have an x coordinate, a y coordinate, a radius, and a height. Okay, then I'm going to call the circle type with the x coordinate, the y coordinate, and the radius. Now, as we just saw, the circle type is going to call this with just it's going to call the point type with the x and the y and take care of the radius itself. Okay, then again, I'm just taking care of the height. It's all we care about. Okay, and that should be it. Okay, and then I think there's another type with test. Is there? Maybe there's not. I had a test somewhere. Cylinder test, it's called. Apparently it was getting too long. Losing the ability to spell cylinder. There we go. It still doesn't like it. It's one of those days. So what did I call it? Oh, I did call it cylinder with test. That's made the executable different. There we go. What I did before, wrong. So in my main, I'm just testing everything here. Okay. So I'm creating a cylinder. I'm outputting with the get radius, the get height, the area, the volume. I'm having them enter a new radius and then enter a new height and then printing that stuff out again just to test it all. Okay. That's what I was looking for on that. Okay. So the other problem also led to some difficulties for some folks, and that's going to be the student problem. Okay. So I could have made it clear, and you guys could have asked questions. Some of you thought I wanted you to do the array type, safe array type class that we did as to store the data, and you didn't need to do that. Okay. So it was enough just to do a normal array. So I can do a string for name. Tabs, make sure we're okay there. Okay. And I'm going to call it exams. That's a pointer. That's my array. Okay. And I probably should have some comments there, but I don't. But remember, the problem said you only want them to be able to do 10. And I think it makes more sense for them to access those as 1 through 10 rather than 0 through 9. So we have to make that translation for them. Okay, make it easier on the user. Okay. So we're going to start here, as we always do, with our constructor. Okay. So this is our student. Let's say it needs a name. So we're going to take a string in here. Okay. Name is equal to n. And I'm going to create an exams array. So it's a new float of size 10. Okay. And I think for it to make sense, I'm going to go ahead and initialize that to 0. So for int I equals 0, I is less than 10, I plus plus. For each one, I'm going to set exams sub I equal to 0.0 since they're floats. Okay. So that should take care of the constructor for me. Okay. So going back to the rest of the things that we may need, and I can go ahead, and if we want, it's not a bad idea, do int main student S1 Bob, our friend Bob, not Gob. That's all we can do right now, but that should work. It does not hurt. In fact, it's a good idea to compile more often and catch errors when there's not much code there. Okay, so we're good. We can always also, just in case there's not a segmentation vulnerability, and there's not, we're good. Okay, so now I'm going to go back and add some accessors here. Okay, so the first accessor we're going to have is going to be the get name. Okay, so that's a string is what it's going to return. Get name. It's going to return name. Easy enough. Now, the other accessor is going to be on the get exam. So you have to figure out how you want to do this. There's some options. You could do a get exams that just prints them all. That's fine. Or we can get a particular one, which is going to take an int, let's say I. Doesn't matter what you call it. Okay, so in this case, what we're going to return then is exams I minus 1. Again, if they say they want the first one, the first exam has an index of 0 because of the way C++ deals with things. Okay, it deals with arrays. Okay, so that's what that will do for us. Okay. Then as far as the mutators go, we have to have a way for them to add new exam. Okay, we'll start with set name. Set name first, which will take some string in. We're not doing any tests on that. It's the name to be whatever they want. This name is equal in. Okay, then we're going to have a void function for set exam. You could call these something different. Doesn't matter. Okay, so on the set exam, it has to have an index position I, and it has to have a grade. Okay, so once you have that information, we have to be concerned if we're getting a valid set exam. We can only have 0 through 9 or 1 through 10 in terms of the user. So we have to make sure that our values are in the correct range. Okay, so I'm going to say if the index they've selected is greater than 0, the and is 2 ampersands, and the index is less than 11. Okay, so it's between 1 and 10. We know we're in the right range. Okay, again, I'm looking at the 1 through 10, not the 0 through 9. Okay, I can set exams sub I equal to grade. Okay, else I can give an error message here. It's a void function, so I don't have to return anything. I'm not returning anything in either case. I'm just going to say exam number between 1 and 10. You'd want more of a message, but in trying to save time, that's all we're going to do. I'll take them back to wherever they came from. Okay. So that should be the set exam for us. Okay. So for other functions, again, this is where the fact that we have an array, it's the point of this problem. Since there's an array, I originally said we needed a destructor, but we have found out we don't need a destructor. It's automatically done for us. Okay. But we do need to have a second constructor, okay, a copy constructor. And we also have to override the assignment operator. Okay. And we can go ahead and override the assignment operator here. Okay. So this looks like this. Let's say a constant student address, okay, student ampersand, operator equals, overriding the equal operator, okay, constant student address other, okay. I'm going to say if this does not equal the address of the other, okay, I'm going to set this name equal to the other dot name, and this dot, or this dash greater than exams is equal to other dot exams. Okay. Now, a point comes to mind here that I have not fully tested yet. This is going to move over the array pointer. This is not going to be enough. This is not going to do it because, yeah, the issue here is going to be, this will still do a shallow copy. Okay. So what I'm going to have to do here is I'm going to have to do my loop here. And I equals 0, I less than 10, plus plus. I'm going to have to go through and set this exams sub I equal to other dot exams sub I. Okay. So that should take care of it for us. Okay. We'll see if this works. No, it blew up everywhere. Oh, hope that's the only issue. I have an N somewhere instead of an end L. If you ever get anything wrong with any of those, I didn't note which line that was on. If you get like the stream operators, these guys the wrong way, you will get a page full of messages like you've never seen in your life. Well, we just saw them, so now you've seen them. Yeah, that was all that was going on there. Okay, so it didn't do anything, which is fine. Okay. The other thing we have to do is the copy constructor. Okay. So the copy constructor is going to go in the constructors section. It's again going to be a student. Okay. It's going to take a constant student reference to a student there, other. Okay. And for this, again, name is equal to other name, works just fine. But as before, I'm going to have to copy this for loop. Again, tabs will make sure everything's straightened up. Oh, yeah, I'm missing a bracket. That's better. But this time it's going to be just exams sub I is equal to other dot exams sub I. Okay. So we should be able to say something like student to Alice, and then I can say like S2 is equal to S1. Okay, and then I should be able to change things without causing any trouble. Okay, so that's why we do the copy constructor. Okay, but for a different test, our student Bob, let's go ahead and do a cout s1 dot get name. Do that name. Okay, we have a change name option. Okay, so we can do a set name else. Okay, and then let's go ahead and do some set exams. Okay, do a set exam. We want to set exam 1 equal to 95.4. We do an S1 dot set exam for exam 2 at 88.2. Okay, we can certainly do more there. Okay, but know that we have defaulted all the other exams to 0, so we're not going to get just random numbers. Okay, so I could either do a little loop here in order to print out all the exams, or I'm just going to go ahead and add a function. I think that makes more sense. So under the other here, I'm going to go ahead and do a void print exams, not a get exam, but a print exams. Okay, and for those, again, for int I equal to 0, it's less than 10. No, to print these out, I want them to print out like they expect. So I'm going to do I is equal to 1, I is less than 11, plus plus. Okay. So now, and again, the reason I'm doing that, I'm going to use the get exam, which wants the 1 as the first element, not the 0. Okay. So this should work out. So when I go through each time, I should be able to do a cout I, that's the test number. Okay. I'm then going to do a tab character. So that's just in single quotes, the \T. Okay. I'm going to do an S1 dot get exam at that I position. Okay. If I would have left that 0 and 1, then it would have a 0 test, which we don't want. Okay. This will take care of that one for us. Okay. All that does, so I should be able to come down here. And of course, you can pretty all this up. An S1 dot print exams. Okay. See what we got here. Doesn't like get exam. Why doesn't like get exam? Why didn't like S1? Well, that's a good question. Let's see. We've got S1. Why did it only not like it one time? Didn't like that. I wonder if that's just a typo there. It's on line 43. See if that's an L instead of a 1. Oh, because we have no S1. Since we're up here, it's this. It's whatever called it. That's what the trouble is. There's no object there. That should work. Okay. And there you go. Okay. Although I clearly have messed up in doing my exams. I did a 1 and a 2, I thought, but it did a 2 and a 3, which means I've got something wrong on my set exams. Yeah, that should be I minus 1. That's where I'm at. That's what I need. Let's try it again. Yep, got it. So exam 1 was at 95.4, exam 2 is at 88.2. Okay. So that's what I'm looking for there. Again, make sure, I'm not sure I tested all the functions, but you should. But that's the idea. Okay. And again, we needed the copy constructor, and it has to go through the loop, copy all that stuff. You have to, here's where we're overriding the assignment operator, the equal sign. Okay. So we're going to go and do that and change all those. And we do need this there because it's what's coming in to the function, what's calling this function. Okay. This refers to what's on the left of the equal sign. So when we said S2 equal S1, S2 would be what's the this is. Okay. Okay. Then we also did the copy constructor down here. It's also going to go through the loop and copy all those items so we don't have aliasing. Okay. And we're going to do our test program. Okay, that should do it. So if you have any questions about any of these problems, I'm going to put all of my code over in the /tmp directory, so you should be able to access it. But if not, that's all I've got for this. Let me know if you have any questions.